Jessica Drake, and I'm a consultant in HO strategy, and I have the pleasure of being your moderator or the keeper on timer today. And our first lightning talk today is presented by SafeCrit, who is the Water Tower's newest transformative partner. And they're going to be talking about technologies for protecting critical infrastructure. And I have been practicing all morning. Aditya Mathur and Siddhant Srivastava.
Thank you. Good morning, everyone. My name is Aditya Mathur. I am currently a professor and center director of iTrust in Singapore. Before this, I was for 30 years at Imperial University in West Lafayette, fourth place, and before that at Georgia Tech for about 2 years. So today we are going to present a set of technologies that we have developed in Singapore for protecting water plants against what I call as extreme cyber attack. Excuse me. So this is supposed to be a lightning talk for 30 minutes, but it's going to be lightning talk for about 15 minutes, followed by lightning demo for about 15 minutes. So we may not have time for questions, but you're most welcome to come to our booth. Three of us, myself, my colleague Siddhant, and another colleague Mark will be available. And also our partner SafeCrit will also be available for any questions. So let me start. All right. So iTrust is a center for research and development in Singapore, and it was set up by the Ministry of Defense in Singapore in 2012. And from 2012 until now, they have been extremely generous. The government has been extremely generous to iTrust. We have been developing technologies, and the unique thing about iTrust, I must say, truly unique thing about iTrust is that we actually have a set of 4 test beds in the area of water, treatment, distribution, and power, and IoT. And we are building a fifth one now in maritime security. So that's iTrust. SafeCrit is our exclusive partner for commercialization of the technologies that we develop in Northern America. So Mr. Pundi Narasimhan, who's sitting at the back, is one of the well-known entrepreneurs in the greater Atlanta area. And he has been setting up many companies in the past and has been very successful. And now this, he says, is one of his last innings of his life. He wants to take care of all the water treatment plants in America and install this technology in these plants. So I'm really happy to work with Pundi and his huge team here in North America. Now, first, let me explain what we mean by extreme cyber attacks. So those who provide technologies for cyber defense generally make the following assumption. The assumption they make is that we have done as much as we can for safeguarding our infrastructure. And when I say as much as we can, I mean I have firewalls, I have authentication mechanisms, I have access control mechanisms, etc., etc. We don't make that assumption. We make the assumption that regardless of what you have done, a smart cyber attacker will be able to get in. What do you do now? That's where our technologies come. Our technologies are not just anomaly detection, but they go beyond anomaly detection. And that's what you will see today. All right. So there are 4 steps. Essentially 4 steps to actually defending a plant, not just raising alerts. The first step is anomaly detection, and we have technologies that SafeCrit has been licensed to, which based on artificial intelligence design. This is quite common as far as AI is concerned. It's used by almost every vendor that provides anomaly detection, uses AI, machine learning. We use that, but the unique thing about our technology is a patented technology based on design. By combining AI and design, we are able to keep the rate of false alarms to near 0. And we have shown that in a pilot in one of the large plants in Singapore. The second step is something called an IT/OT bridge. Those of you who have seen anomalies generated out of the commercial software that's available for anomaly detection, you would agree with me that the anomaly alerts that are generated are based on network packets, network anomalies. We have IT, which is network anomalies, and OT. So we have a bridge so that the anomalies that are generated, the alerts that are generated, are aimed at both the plant engineer who's sitting in front of the HMIs and monitoring the progress of the plant, as well as the network specialist who might do forensics in order to remove the attacker immediately or sometime later to find out what happened. So that's our ITO debate. The third, which is one of the most interesting technology that we have, is command validation and asset protection. What does that mean? Whenever a cyber attacker is able to access the plant and able to spoof the values of certain sensors, that might lead to a PLC to send a bad command to an actuator like a pump or a valve or generator and so on. That's where we come in. We are constantly monitoring all the commands being sent by the controllers to the actuators. And we are finding out every time, every instant, whether this command is valid or not. Now, you might ask, what do we do after that? We have two options. That depends entirely on the management policy. If the management allows us to send a command, which is rogue command, to the actuator, we do that. If the management does not allow that, then we don't do that. But we inform the plant engineer in any case that this PLC is sending rogue commands for this reason. Okay, so that's our command validation and asset protection, because we can actually protect your asset. For example, we choose an attack, a chatter attack, which might actually damage a pump, and we can protect the pump from being damaged by a chatter attack. The last one, which is the most complex of our technologies, is plant control. So what we have done is we have developed a digital twin, quite a safe and secure digital twin, which connects to our plant. We have an actual plant that you will see in the video in a moment. We connect the twin to the plant. The twin is constantly receiving state of the plant, and it is generating anomalies. So that's fine. But when an attack like what happened in Colonial Pipeline happens, then if the management wants, the twin can take control of the plant, which means the twin can actually stop the commands that are coming from the PLCs to the devices and actually take control and run the plant. Now, I suppose all of you will say, whoa, is that possible really? And should we do it? No, I'm not saying you should do it, but I'm saying, yes, it is possible. And I should not also say you should not do it, but you may have to do it, such as what happened in Colonial Pipeline. They need not have shut down the pipeline. They need not have shut down the pipeline. But when a ransomware attack happened and the FBI was calling them and they did not know what's happening in the plant, they had no choice but to shut it down. That's where the digital twin comes in. It can maintain the access to the plant, the view into the plant, despite a ransomware attack. So let's go to the next one now. So I'll introduce you to our demo team first, then the setup, then Siddharth and our demo team in Singapore will give you a lightning demo of the attacks that we launched, and you will see some of the anomalies. Now, unfortunately, because the time is very limited, I will not be able to explain to you the details of the anomalies, but all the anomalies that are being generated in Singapore while the attack is going on live. By the way, the plant is running live right now. It's about 8:45 there in Singapore. All those anomalies I'm saving here on my laptop. On my laptop, I'm getting the data directly from Singapore, and all the anomalies generated are being saved in my laptop. So anyone, if you want to know what's happening, you can come and see me later. I'll show you what were the anomalies that were generated while this demo was going on. All right, so let's introduce the demo team. So we have Gautam here. Gautam is sitting. We have a control room there in Singapore that controls where we control our plant. So we have Gautam Raman, who is the inventor of our AI technology, which makes use of AI, machine learning, as well as design. We have Ivan Christian sitting in Singapore. He's an expert in deploying our digital twin in large exercises. So our digital twin has been deployed 3 times in NATO exercise Lock Shields. Some of you might be familiar with that exercise, which is where 2,000 or plus people participate. So he's the one who actually handles our digital twin in NATO, because it's quite a massive exercise, and installing the digital twin is a real pain there. We have Sanskar. Sanskar is one of our youngest research scientists. He actually is one of the developers of the plant protect technology that I'm going to show you later. Then we have Anand. Anand is our SWaT engineer. He actually manages the plant. So whenever there are issues with the plant, he is the one who takes care of that. Now, let me introduce you to the demo setup that we have. So, as I said, this is one of the pictures of the plant, and this is the HMI of the plant, the real plant. And what we'll do is to give you a quick overview of the plant, which we are going to use in this demo. Okay, so we are entering the plant from here, and I am looking at this raw water tank. The water from outside, which is to be filtered, comes into this tank. This is this has Allen Bradley controllers right here, which will actually control the valve that is moving the water into this plant, and also the pump that you will see in a moment that is moving the water out of this tank to another tank in stage 3. So this is the stage 1 raw water stage, and you can see this is the control rack with the PLCs, dual PLCs, Allen Bradley, and RIOs and so on. Why did it stop? Okay. Yes. And now the water from stage 1 is going to move to stage 2, and this is where the pre-treatment is done. And you can see some of the chemical parameters, and these are the chemical dosing pumps. So there are 3 different chemicals for pH, ORP, and conductivity. And there's a controller for this. From here, the water goes into stage 3, which is the ultrafiltration stage. And this is the controller for that. And this is the pump that is used to move the water through this ultrafiltration unit, this white cylinder that you can see here. And this has membranes, fine membranes that clean the water. And this water goes into the RO feed tank, which is T401, that you'll see in a moment. That's the RO feed tank. From here, we actually take it through dechlorination. And you'll see the dechlorination unit in a moment, which has 8 UV lamps. And there you go. Right here, yes. The water goes through this, and that free chlorine is removed here. And this water without the free chlorine is moving to stage 5, where we do the RO. So these are the RO cassettes, which are very fine membranes, and that's where reverse osmosis is done. The RO output, the 2 streams come into RO product, the permeate and the reject, and this permeate is recycled. So that's a very quick overview of the plant, which is in Singapore and which is right now running, and which we are going to attack in a few moments. Okay, so we can launch in that plant. For the last several years, we have been launching several types of attacks. We launch physical attacks, insider attacks, cyber attacks. Physical attacks we can launch because the plant is ours. We go there and remove a wire and see what happens and whether it is detected or not. Insider attack is like a plant engineer sitting there, or like we from here getting access, and we can launch attacks to the plant through SCADA and HMI. And cyber attacks are the attacks to the communication network. This is what we are going to do today. We launched 3 attacks through the communication network. So we are assuming that somehow the attacker has gained access to the plant network somehow. Okay, so now the systems that are going to be used in this demo, of course, the attack target, as I said, is the secure water treatment plant. We have 2 detectors, DAT and AIGrid, which are now called SafeGrid. They are licensed to SafeGrid company. The detector host, the entire system is hosted on a digital twin. So the twin is receiving the data from the plant, and it is sending the data to the HMIs and to the detectors and recording the data, etc., etc. And then we have the various demo components, HMIs, the engineering workstation detector, and there's the OT visualizer, which visualizes the state of the plant and tells you what are the anomalies detected, etc. Then we have the technologies we are demonstrating today are the anomaly detectors, which are DAT and AIGrid, as well as the IoT bridge and command validation. Because of the shortage of time, you may not be able to see all the anomalies right here. We generate the anomalies. I should say we actually delay the alert by about 15 seconds. But because I'm going pretty fast, lightning. Okay, so I won't be waiting for the anomaly to come for 15 seconds. Some of the anomalies like chatter, we wait for about a minute. I'm not going to wait here, but the anomalies will be generated. You may not see them right here, some of them, but you will see them on my laptop later because they are being recorded. All right. So now time for demo. Siddharth,
all right. I request the team in Singapore to share their screen so we can start with this demo. And this will be a complete show and tell. So once they share the screen, I'll describe what the different screens mean.
Can you see the screen?
Yes, we can see the screen. So So what we see right here is an anomaly detection or visualization. And the plant, which was just described by Professor Mathur, is in the HMI. So let's see the HMI. So to describe the detector screen, I'll have to first show you the plant HMI. So this is the HMI for the 6-stage water treatment plant that we just saw. And as we can see, there are 6 stages. So Prof will annotate. There's the first stage, second stage, third stage, and so on. And we'll see how very simple attacks, which can be launched on a plant like this, which is very representative of real world plants, can lead to disastrous consequences. And even besides the realm of attacks, if there's a maintenance issue in any of these components, our detection tools and SafeThreat technologies will be able to demonstrate in plain English what the exact error is, so that it's not only helpful for the plant operator, but also senior management as well as the IT network team. So there's one more tool that we are using to launch attacks, which we will show. It's called the attack desk. So
attack desk is developed in iTrust. It can be used to launch attacks on the print as well as on the plant, the real plant. It accepts various kinds of protocols.
So attack desk is a simple tool which abstracts away the complexity of launching attacks on the network. So here we see in plain English that the first attack that which we want to demonstrate is the Maruchi-Shire sewage spill. So before starting this attack, let's look at the detector screen and see if there's any anomalies before launching any of these attacks. So
you can see here, for example, that has generated 330 anomalies. Why are these anomalies coming? Unfortunately, the SWaT that we have, the RO unit is not working properly. And as a consequence, the flow rate, even when the pump is running, there's a problem with our RO. We had just gotten it maintained, but I don't know why this problem still exists. Because of that, the pump, one of the pumps stops and then restarts. And because of that, there are quite a few anomalies that are being generated constantly by that. And that's why you see the 320, 321. This number changes because it is during the last 5 minutes or so. That's why this number is changing. But I'll show you these anomalies later if you want to see the details. Next.
Yeah, and all the attacks that we see will be correlated with the actual physical values in the plant. So I'll be showing you live footage from the plant in Singapore. It's around 8:50 p.m. There right now. So all the anomalies you see here are in Singapore time, like 20:45. So let's start with launching our first attack. So I request Chris to show the attack desk, and we will see what the exact attack is.
Launching the attack in 3, 2, 1.
Okay, so the attack has been launched. This is an attack which is representative of a 2001 attack on the Maruchi-Shire sewage spill. So this was a cyber attack launched in Australia, which released 1 million liters of sewage water or dirty water into natural water bodies. And that was an overflow attack. So that was done by a disgruntled employee of the plant. So as you can see here, there's a lot of components that were modified. So we see a valve here, which was open, a motorized valve. It was red earlier, now it's open, which means it's letting in raw water into this tank. Then we see that the value of the tank is constantly changing or fighting between 2 different values. So from the live footage, we see that the value of the water in the tank is actually quite close to the maximum. So the attacker is trying to spoof this value to a lower value. So you see that sometimes it spoofs it to 400. And this is, if the attacker is smart enough, they can keep it at 400 without the plant engineer ever knowing that they are modifying it. And we also see that this pump is now red, which means ideally it should be green and pumping out all that extra water from the tank to the next stages. But the attacker has managed to switch off the pump, so as to force all the water to just come into the tank. And eventually this will lead to flooding in the facility. Very similar to the attack on Maruchi-Shire in Australia. So now let's see if we were able to detect this particular attack or not. So if this attack is not stopped on time, this tank will physically flood.
So I know you cannot read this anomaly, but our ITOT bridge is now telling you, for example, that abnormal network packet detected, and all the details of the IP addresses and MAC addresses are here. And then it also says there's an attempt to change the, where did it go? Okay. And the tag, to change the LIT values, and the tags that are affected are MB101, and the attacker intention is attempt to change the state. So that's what iTrust has detected, and similar, there are similar detections here. LIT101 predicted value does not match the observed value. Check FIT101, FIT201. So the alerts that are generated are aimed at not only the plant engineer or not only the network engineer, but at both, which is quite unlike what I have seen with the commercial tools.
Yeah, these plain English descriptions are very helpful in case of an emergency cyber attack. So now we move on to the next attack. So we see the graph of anomalies peaking around this time. So even after the fact, these attacks can be analyzed. I'll describe the next two attacks. These are based in both of them are based in the US, and some of you might be familiar with the Florida water plant attack, but I will first demonstrate the attack, which is attack number 2, which is representative of a cyber attack that happened in 2011, which resulted in the destruction of a pump. So a pump in Springfield, Illinois, in a water pump station, got destroyed because of either a maintenance issue or a cyber attack. But this either of those cases would be detected by a technology like SAFE. So asset protection would have saved this kind of an attack where a pump gets damaged and the whole plant comes to a grinding halt. So this particular attack basically switches on and off the pump. So this is the chatter attack in which the pump goes on, off, again and again. And we will focus on the pump in stage 3. So if we look at the ultrafiltration stage, just take a look at this pump. You will see this flash red and green continuously. And we'll show you with live footage what that looks like. So I request Chris to start the attack. And I'll have to request him to stop it very soon. Otherwise, it will damage the pump and we'll have to stop the plant. So
starting in 3, 2, 1. So
the attack was launched, and now you will see sounds coming from the pump, and we will also see yeah, so you see it's the A has been changed to M, which means automatic has been changed to manual mode. And we also see some glitches in the value, which is intentionally done by the attackers.
You can see now these pumps are chattering. They can stop it quickly.
You have to stop it quickly to prevent any damage.
Just to give you an example, this chatter attack is very interesting because chatter in pump 301 causes a cascading effect, and it causes chatter in the following pump in the stage 4, which we are not seeing here, but that causes chatter, and that is also detected. Okay, next.
Yeah. So finally, we have the last attack, which firstly, let's look at the detector screen. So see how we missed looking at the detector screen when the attack was going on, which is very representative of a real world scenario. Attacks are never analyzed at the time of the attack. They're always analyzed after the fact. So we look at this peak in different anomalies here. And now let's look at what the different alerts say.
So the similar kind of thing is that there's an abnormal change in analytics 301. Here you will see a little later the chatter attack, but you won't see it now. If you wait for some time, you will see it, but I won't wait. You will be able to see it on my laptop later. So all the anomalies that have been generated have been detected. Some will take the chatter attack. I have given it's a tunable parameter. I have given it 60 seconds before the attack is actually reported. For some, it is 15 seconds. For this one, I have given it 60 seconds. But this is a tunable parameter.
All right. Now we come to the last attack or the most recent attack. So you might have seen the first attack was 2001. The second attack was 2011. The last attack is 2021. So all of these are 10 years apart. And we can still see how easy it is to launch attacks. So this is based on an attack in a Florida water plant. So the first one, Marucci-Shire, was a wastewater plant. The rest of the two are drinking water plants. And Florida water plant attack essentially was a chemical overdosing attack in which one particular chemical, sodium hydroxide, was released into the water supply. And that attack in Pinellas County in Florida resulted in a lot of damage, or could have resulted in a lot of damage if it was not stopped on time. So in this case, we are doing this attack with thrice the impact. So we are not releasing one chemical, but 3 chemicals simultaneously into the water supply. So if we go to stage 2, which is the pre-treatment stage, so the legitimate role of this stage is to clean the dirty water coming in and to kill the bacteria with acid and different chemicals. But if these chemicals are released in large enough amounts, they can also be dangerous for human consumption or any consumption afterwards. So you see that there are 3 different chemicals here. There's sodium chloride, there's hydrochloric acid, and sodium hypochlorite. And to prevent a lot of acid being pumped, there is a pH meter here. So these sensors essentially check if the water is too acidic or too basic, or if it's within the safe parameters to move the water to the next stage. So there's a valve which prevents the water or allows the water to go to the next stage. So to replicate the Florida water attack, we will switch on all these pumps. So all these red pumps that you see here will go green, which means all of them will start pumping all these chemicals. The attacker is smart, so they will spoof the pH value to a very high value. So ideally, if acid is coming into your water, the pH should reduce because acids have a low pH. So even though actually in the physical world that the pH will be low, on the meter, it will say that the pH is actually high. So it's very safe. And at the same time, to allow the water to go to the next stages, this valve will stay open and it will be forced to stay open. So yeah, let's start the attack and see the consequences of that attack on our detectors as well as the team.
All right,
These are
starting
the
in 3, 2, 1.
attacks have started. We can see the pump sound. Now we can also see that all the pumps have turned green, and the pH value is constant at 10. It is chemically impossible because there's different chemicals coming in the water supply, and the valve has also been manually opened. It won't close on its own, even though the plant logic and the programmable logic does want to close. So this is the impact of Florida style water attack. Now we'll see if our detector was able to detect this or not. Yeah, so we see a peak in the values around this timestamp. And we also see plain English description by the AI detector, the machine learning based detector, as well as the design detector, which has chemical rules encoded that the pH of the water can never be this if these pumps are on. So, yeah, Professor Aditya can describe some of these.
Yeah, so you can see here, there are a lot of detections going, anomalies detected, and the details are all, you cannot see this, so I'm not going to read all this stuff, but you can see this later. But all these anomalies are detected and they have been coded.
Yeah, so these are the 3 attacks. So yeah, if you want to launch a custom attack, you can come to the booth and the control room later to discuss if you want to do that. But yeah, otherwise that's the end of the demo.
Thank you. So this was lightning demo, lightning talk. And do we have time? There's some more time for questions?
It's 9 o'clock exactly. If you guys are okay to stay a minute or 2, you're welcome to. Otherwise, you can go to the booth, whichever you're comfortable with.
Maybe one quick question if anybody has. One quick question, I'll give a quick answer.